Good day, guys. This is your tutor engineer. We are continuing today with graphs and motion. So let's start with today's lesson. A suburban London train leaves central London to Windsor station, accelerates uniformly westwards from rest to reach the speed of 40 meters per second in 16 seconds. After maintaining the speed for 60 seconds, it brakes uniformly to come to rest at Windsor Station after a further 24 seconds. 26.1 Sketch the velocity time graph for the journey. Okay, so let's do so. So what do you have? You have the train starting at London, heading off to Windsor Station. So we're going to write London here, and then Windsor Station is this side. Okay, so we're told that the direction is westwards, so west will be positive. It starts from rest, meaning velocity will start from 0, and then speeds up to 40 meters per second in 16 seconds. So this is going to be our time axis. So it's gonna accelerate from 0. The train will accelerate from 0 up until 40, right? So from 0 to 40, we'll just draw a line, straight line that's gonna connect 0 and 40. So this is a straight line. It's supposed to be a straight line. It's supposed to at least look like a straight line. So let's just try and make it as straight as we can. Okay, now it looks better. After maintaining the speed for 60 seconds, it brakes uniformly to come to a rest at Windsor Station. So we are told that this speed is going to be maintained for a further 60 seconds, which will be at 70. So when you add 60 to 16, you come to 76. So it's going to be the same speed of 40 meters per second for 60 seconds, and then it's gonna come to a rest at the Windsor Station. So this is where the brakes will be applied for a further 24 seconds, which will take us to 100. So this is going to be our velocity time graph. Let's just label the time axis, and then this is going to be our velocity axis, and then that will be it. Let's go to the second question. Use the graph in 26.1 to determine the acceleration for the first 16 seconds. As you might know by now from our previous lessons, if you are given the velocity time graph and you need to determine the acceleration, that means you always have to work out the slope under the velocity time graph. So this is going to be the area of interest, right? So even though you're not calculating the area, but we're going to calculate the slope. So we have to identify the coordinate here, which is 16 and 40, and we know at the origin is 0 and 0. So to calculate the acceleration, we're going to say v2 minus v1 divided by t2 minus t1. So v2, we know that it's 40. Let's just change the color now. v2 is 40, and then v1 is 0. So here we'll say 40 minus 0 divided by 16 minus 0. That will give us 40 over 16. Then the acceleration, we can easily calculate it as 2.5 meters per second. Since it's positive, we'll write west direction. So that's the answer. And then let's go to the second part of the question. Calculate the distance between central London and Windsor Station. So we're going to work out the distance from London to Windsor Station. It means now, since you are given the velocity time graph and you need to work out the distance or displacement, that means now you need to deal with an area under the velocity time graph. So we're going to deal with this area, calculate this area, and then calculate the area of the rectangle, and then finally calculate the area of this triangle at the end. So let's start with the first triangle. Let's call it change in x1. So what do we have here? We have 16 as the base, and then the height is going to be 40, right? So let's work out the first area, which is half base times height. The base is 16 and the height is 40. So 16 times 40 divided by 2, I get 320 meters. And then let's calculate x2. Likewise, the base is going to be 60 seconds, and then the height is the same as 40. For a change in x2, because it's a rectangle, the area is base times height. The base is 60 and the height is 40. So 60 times 40 gives us 2,400 meters. Now let's calculate the area of the final of the triangle here at the end. The base here is 24 seconds. The height is the same as 40. So since it's a triangle, we'll have half base times height. The base is 24. The height is 40. So the distance would be 480 meters. So therefore we can conclude that the distance between central London all the way to Windsor Station is equal to the summation of all the distances that we calculated. So the sum would be 3,200 meters. Since it's a distance, you don't need to state the direction. Okay, so that's it for today's lesson. If you like today's lesson, please tap that like button and please subscribe. Stay tuned on the next lesson, and cheers.